Welcome to Welder 36 week part 1. Topics to be covered are: number 1, state the properties of argon gas; number 2, compare the performance characteristics of argon and helium gas for tungsten inert gas welding; number 3, identify an argon gas cylinder and ceramic nozzles; number 4, state the uses of argon and helium gas. Introduction. Shielding gases. Chemical activities of shielding gases. The behavior of gases in welding is related to their chemical activity, so it is convenient to group them according to this activity. Inert gases. These are argon and helium. Other inert gases such as krypton, radon, xenon, and neon have been tried, but their low availability results in them being expensive. Pure argon, for example, does not allow a smooth droplet transform when welding carbon steels. To obtain the desired transfer mode, it is necessary to add a certain proportion of oxygen or carbon dioxide. Properties of argon and helium gases. These gases are colorless, odorless. Argon is heavier than air and helium is lighter than air. They do not chemically react with any metal in hot or cold conditions. They give a good shielding action for molten metal from the atmosphere. Gases for tungsten inert gas welding of aluminium. An argon cylinder is identified by the peacock blue color painted on it. Quality. Argon gas of welding quality should be used. The rate of flow of argon should be adequate to obtain a clean weld. If tungsten inert gas welding has to be done outdoors during inclement weather, especially during a period of high wind, the welding area should be effectively protected. Draughts tend to break the gas shielding, resulting in porous and oxide contaminated welds. The penetration profile of argon shielded welds has a characteristic shape in the form of a finger shown in figure. Helium. Helium is used mainly in tungsten inert gas welding and is normally used with direct current whatever the metal being welded, light alloys, copper, etc. The main advantage of helium shielding are: increase in welding speed, more intense local heating, important with metals which are good conductors of heat. Figure shown the penetration profile typically of a helium shielded weld. Argon gas gives more penetration than helium gas. Characteristics and comparative performance of argon and helium as shielding gases. Low arc voltage result in less heat. Thus argon is used almost exclusively for manual welding of metals less than 16 mm thick. Easy arc starting, particularly important in welding of thin metal. Arc stability is greater than with helium. Low gas volume. Being heavier than air, argon provides good coverage with low gas flows, and it is less affected by air drafts than helium. May cause porosity and undercutting with welding speeds of more than 60 cm per minute. Helium. High arc voltage results in a hotter arc, which is more favorable for welding thick metal over 5 mm and metals with high heat conductivity. Small heat affected zone. With high heat input and greater speeds, the heat affected zone can be kept narrow. High gas volume. Helium being lighter than air, gas flows is normally 11/2 to 3 times greater than with argon. Automatic welding. With welding speeds of more than 60 cm per minute, welds with less porosity and undercutting may be attained depending on work metal and thickness. Here you can see comparison between argon and helium shielding. Thank you.